Hello all. Today our topic is stereochemistry. Okay, so if they are giving you some Fischer projection, how to find out that the given projection is R configuration or S configuration? That is what we are going to see in today's video. Okay, so it is very simple. It is based on CIP rule. Okay, we are going to predict whether the given substance is R configuration or S configuration based on the SIP rule. So what SIP rule states is you have to give the priority for atomic number based on atomic number. If suppose you are having fluorine, chlorine, bromine and iodine, which is having highest atomic number here, obviously it is iodine, right? Hence, the first priority should be given to the group that is having highest atomic number. Okay. Hence, this should be given first priority. This should be second and third, fourth. Okay, you have to give the priority based on the atomic number. This is what is SIP's first rule. Okay, suppose if it fails, see in this case hydrogen, deuterium, tritium, both are having same atomic number, right? 1 1 1. These are all nothing but the isotopes of hydrogen, so they will have the same atomic number. In that case, what you have to do is you have to look for the atomic mass. Okay, if they are having same atomic number, then just go for the atomic mass. See, in this case it is having a mass number of 1, right? 1, deuterium is 2 and tritium is 3. Hence, which is having highest atomic mass here, it is tritium, right? Tritium. Hence, it should be given the first priority. Okay, it is first and this is second and this is third one. Okay, very simple. First you have to look for the atomic number. The group that is having highest atomic number should be given the first priority. Then the second rule, if it fails, if all the groups are having same atomic number, then just look for the atomic mass. The group having higher atomic mass should be given the first priority. Okay, this is what the second rule. Next, if there is multiple bonds, okay, if there are multiple bonds, convert it to single bonds. Okay, convert it to single bonds. See, for example, if you are having carbon-carbon double bond, okay, in that case you have to consider it as like carbon double bond means single bond carbon, single bond carbon. You have to convert that into single bonds. Okay, suppose if you are having carbon triple bond carbon, then you have to consider it as, see, 3 carbon atoms. Okay, this is how you have to convert the multiple bonds into single bonds. Don't worry, if we work out example, you will be very clear with the concepts. Okay, I'm just giving the rules. After that we will solve many questions, so you'll be clear. Okay, let us solve one example so that you will be clear with the concepts. Okay, so suppose if you are having fluorine here, hydrogen, chlorine and bromine. Okay, so first of all, what you have to do, you have to give the priority, right, based on the atomic number. Here all the groups that are attached to the central carbon are different. They have different atomic numbers. So it is very simple. Which will have higher atomic number here? It is bromine, right? Bromine will have higher atomic number. Hence I have given the first priority. Then among chlorine, fluorine, hydrogen, chlorine will have higher atomic number. Hence it is second priority and this is 3 and this is 4. Okay. Now it is very simple. You have to just rotate from 1 to 2, 3. 1, 2, 3. They are moving in the clockwise direction, right? It is clockwise towards your right. Okay, clockwise direction. So clockwise means it is R configuration. Okay, clockwise means it is R configuration. But this is very important. See the fourth priority group. Okay, the fourth priority group should be present in the vertical plane. Okay, should always present in the vertical plane, right? Fourth priority group should be in vertical plane. But here in this case, it is present in the horizontal, right? It is present in the horizontal line. So what you have to do is, you have to invert the configuration. If you are getting R configuration, then you have to invert and say it as S configuration. Okay, suppose if you got S configuration, you have to invert it and it should be R configuration. Okay, first of all, what is R and what is S is, R means rectus, okay, rectus, and S means sinister. which means R means right and S means left. This is clockwise direction, this is anti-clockwise direction. Okay, this is what the difference, right? This is how you have to find out that whether the given substance is R configuration, is an R configuration or S configuration. Okay, now I will give you another example so that you will be clear. Okay, say in this case you are having chlorine, bromine, iodine and hydrogen. Okay, now which is having higher atomic number? Atomic number will be high for iodine, right? Hence this is first priority and this is second, this is third and this is fourth one. Okay, now just you have to rotate from 1 to 2 to 3. Okay, 1 to 2 to 3 is in clockwise direction, right? It is towards the right, clockwise direction. Hence this is OR configuration, and you have to look for the fourth priority group. The fourth priority group is present in the vertical position, right? It is present in the vertical line. Hence, no need to change the configuration. Simply you can write it as R. Okay, this is R configuration. In that case, fourth priority group was present in the horizontal line. Hence, you have invert the configuration. You have got R configuration, but the fourth priority group is in horizontal line. Hence, you have invert the configuration and set it as S, right? In this case, it is present in the vertical line. No need to change the configuration. Simply it is R configuration. Okay, this is how you have to find out the R and S configuration in Fischer projection. Okay, now see in this case, these are all having different atomic numbers. So it was very easy, right? Suppose you are having hydrogen, deuterium, tritium and a methyl group. Okay, methyl group. So in this case, what you have to do, first of all, these are all hydrogens and isotopes of hydrogens. But carbon is having atomic number of 6, right? In all these cases, the atomic number is 1. Okay, but carbon is having atomic number of 6. Hence, the priority should be given to the methyl group. Okay, first you have to give the priority based on the atomic number. Hence, this should be given the first priority. Now, if you look, see in this case it is a hydrogen, deuterium, tritium, all are having same atomic number, it is 1. Okay, because they are all the isotopes of hydrogen. What do you mean by isotopes? They are nothing but atoms having same atomic number but different mass number, right? Isotopes means same atomic number but different mass number. So all these have same atomic number but they are having different mass number, right? So if they are having different same atomic number, you have to look for the mass. Which is having higher mass here, it is tritium, right? Tritium means 3 mass number and here it is 2, here it is 1. So the priority should be given to the tritium and then deuterium and last hydrogen. Okay, now you can find out the configuration. What you have to do, you have to rotate from 1 to 3, right? 1, 2, 3. It is moving towards my left, right? Moving towards my left, that is anti-clockwise direction. So anti-clockwise direction means it is S configuration. Okay, S configuration. Now what you have to do, you have to check the fourth priority group. The fourth priority group is present in the vertical line. No need to change the configuration. It is simply S. Okay, it is simply S configuration. If suppose the hydrogen is present in the horizontal line, then you have to change the configuration, invert it. But here in this case, it is present in the vertical line. No need to change the configuration. Simply it is S configuration. Okay, it is S configuration. Now, see this example. In this case, this carbon is attached to 4 groups. Okay, 4 groups. But all are attached to carbon atoms, right? All the 4 groups are having carbon atoms that is directly attached to the central carbon atom. So all are having same atomic number. Atomic number is 6, right, in case of carbon. So what you have to do, how to find out the R configuration or S configuration here is, see this carbon is attached to 3 hydrogens. Okay, 3 hydrogens. But this carbon is attached to 1 hydrogen, another one is methyl group, right? Another one is methyl group. Okay, see in this case, this carbon is attached to a hydrogen, a methyl group, another methyl group, right? Now, this carbon is attached to 3 methyl groups. right? 3 methyl groups. So now you can easily differentiate, right? Differentiate. This carbon is attached to 3 other carbon atoms. This carbon is attached to only hydrogen atoms, 3 hydrogen atoms. This carbon is attached to 2 hydrogen and a carbon atom, and here it is attached to 2 carbon atom and 1 hydrogen. Now you can easily predict that this will have higher atomic mass. Okay. According to SIP rule, the third rule, it is if atom attached to central carbon atom is same, priority should be given as per next prior atom. Okay, next prior atom. So here all are carbon atoms. You can't predict the configuration. So what you are doing, you are looking for the next prior atom. In this case 3 hydrogens, in this case it is 3 carbons. So you have to give the priority for these 3 carbon atoms, and among these 3 here there are 2 carbon atoms, right? So it should be given second priority, this is third priority, and this is fourth priority. Okay, so this is fourth, this is third priority, this is first, and this is second. Now it is very easy. What you have to do, you have to rotate, right? From 1 to 3. 1, 2, 3. How it is moving? Towards the anti-clockwise direction, right? Towards left anti-clockwise direction. So if it is anti-clockwise direction, it is S, right? S configuration. And you have to look for the fourth priority group. See, in this case the fourth priority group is lying in the vertical line, so no need to change the configuration. The configuration is yes. Okay, this is how you have to solve these questions. Okay, this is the case in which you have to convert the multiple bonds into single bond. This is also said in CIP rule, right? SIP rule. So see, in this case the carbon is attached, there is a triple bond, right? Triple bond. So what you have to do, see, 3 carbon atoms. This is how you have to split the multiple bonds into single bonds. Okay, and in this case you are having carbon double bond, so which means carbon attached to 2 other carbon, and there is a hydrogen group, so there is a hydrogen. Okay, double bond means you have to convert them into 2 different single bonds. It is simple. And in this case carbon is attached to hydrogen, hydrogen and carbon, because CH2, CH2, CH3. Hence, it will be like this. In this case, carbon is attached to 3 hydrogen atoms. Now, it is very simple. See, in this case, triple bond, we have converted the triple bond into this. So, the carbon is attached to 3 other carbon atoms. Hence, first priority should be given to this. Second, so in this case, it is 2 hydrogen, 1 carbon, and here it is 2 carbon, 1 hydrogen. So this is second one, this is third, and this is fourth. Now you rotate from 1, 2, 3. Okay, how it is moving? It is clockwise direction, right? Clockwise direction towards your right. So it is clockwise direction, which means it is R. Okay, R. And now you have to look for the fourth priority group. The fourth priority group should lie in the vertical line, but it is in the horizontal plane. Okay, horizontal line. Hence, you should invert the configuration. You are getting R, but you should invert the configuration into S. So, S is the correct configuration for this compound. Okay, this is how you have to solve the question, right? Okay, these are some questions to solve. Actually, I will solve the first question. You have to solve the 3 other questions and share your answers in the comment section. Okay, so see, in this case, how you have to find out the configuration is, methyl group is nothing but CH3. It is carbon atom. Here ethyl group, hence it is CH2, CH3. It is CH3, and in this case it is OH. Now, first of all, you have to look for the atomic number, which is having higher atomic number. It is oxygen. Other 2 atoms are carbon and is hydrogen, so it will have least priority. Here it is directly attached to oxygen. Oxygen will have higher atomic number than that of the methyl and ethyl. Hence, this is the first priority. Okay, this should be given the first priority. Then the second one is, between these 2, ethyl will have higher atomic mass, right? Hence, it is 2, it is 3. Now you have to rotate, right, from 1 to 3. 1, 2 and 3. So it is towards your right, clockwise direction. Hence, it should be R configuration. But your fourth priority group is present in the horizontal line. Hence, you should invert the configuration. If you invert the configuration, it is yes. So the correct configuration for this projection is yes configuration. Okay. Okay, I have solved the first question. You have to solve the other three questions and try to share your answers in the comment section so that I can check whether it is correct or not. Okay, I hope this video will be helpful for you. We have calculated this RNS configuration only in Fischer projection in this video. So in the next video, we'll try to solve it for wedge and dash configuration, and then for biphenyls, spirane systems. There are so many systems, and we will try to find out the configuration for those in the next video. Okay, if you find this video helpful, then kindly like this video and share with your friends. Stay tuned. Thank you so much for watching.